Good morning, everyone. I hope you can hear me. Yeah, you can hear me. All right. So I hope you had all a good first day at the Dash. So by show of hand, how many of you have ever heard of the wall of confusion? Okay, one, two. Okay. Not many. That's a little bit surprising. So what is actually the wall of confusion? The term wall of confusion comes from the early DevOps days, and it actually describes the disconnection between development and operations. And this is because these teams that you see on the left side, that there is a development, on the right side there is operations. These teams have different goals, for example. So developers want to speed up and release quickly. Operations actually want to have stability in the systems. Also, they have different tools and processes. They are often not aligned. And the mindsets are often pretty conflicting. So without shared ownership, they actually work in silos. And code and tickets get thrown around back and forth, so it actually leads to frustration and delays. So the thing about this is, this also often leads to security that is treated as a gate at the end and is not integrated from the start. So actually you introduce with that security risks, like critical controls that are skipped to move faster, vulnerabilities that slip through, or there is no clear accountability. So like it's on the other side of the wall. And to add to this, like I think it's around about 2.5 years ago, right? ChatGPT was released, and actually this is like lowered the barrier for attackers. So anyone, regardless of any technical skill set, can write code, craft phishing mails, generate scripts, and so on to exploit known vulnerabilities. And actually this leads also to much more attacks, and they are often higher sophisticated. All right, once again, hello, I'm Marcel. Like Brandon already mentioned, I worked as a software engineer. And previously, I was also working as a cloud engineer at andsafe. Right now, I'm a product owner of our own developer platform. And yeah, let's start with that. So who is actually andsafe? So andsafe is an insurance company based in Germany. We belong to a much bigger public insurance group, and we were founded in 2019. We actually offer easy to understand or easy to consume insurance solutions for the private and commercial sector. And right now we are 6 years live on the market. We have more than 8 agile teams and more than 80 employees. And we are actually 100% digital company. So we only offer digital insurance solutions. From the beginning, so I joined andsafe 6 years ago when we started. We actually had a really lean and agile organizational setup. And when you work in such an agile setup, DevOps or like collaborating between development and operations is not getting easier, to be honest. So like 3 years ago, so we were constantly restructuring and like improving ourselves, like inspect and adapt. So 3 years ago, we actually changed our mindset a little bit and used team topologies to restructure the whole organization. That meant that we actually had streamlined teams that are focusing on their own product. And we also introduced a platform team that wasn't existing before, that is actually taking care of like repetitive tasks and providing like tools and platforms that the stream-aligned teams can utilize and to get better enablement. So when we ask ourselves what are actually platforms, when I started or when I joined, as I joined the platform team 3 years ago, I actually asked myself, what are platforms? And I quickly found that quote from Evan Botcher that's originating from 2018 that I found really interesting. And he says, a digital platform is a foundation of self-service APIs, tools, services, knowledge, and support which are arranged as a compelling internal product. And I think that's exactly what platforms are. And if you look at the market, you actually have all over the space platforms, like Datadog also is actually a platform. Today I want to talk a little bit more about internal platforms. And like Brandon already mentioned, I'm a product owner of an internal and developer platform at andsafe. And we are actually using platform engineering to develop and operate that platform. Now, if you look at so recently the Cloud Native Computing Foundation released a white paper, and they are actually describing pretty good which attributes make a great internal developer platform. So first of all, and I really urge everyone to do that if you plan to develop an internal developer platform, you have to have a product thinking mindset. So that means you should have like somebody who's doing the product manager, somebody who's the product owner, because you need that interface between your engineering team and your internal customers and stakeholders. Another attribute that's really important is the user experience, because when you do a platform as a product, so product thinking, you actually can provide your users consistent and intuitive interfaces to enhance the usability. Another important thing is you have to have documentation and onboarding, and also self-service that enables your users to autonomously provision and manage resources, which actually reduces dependencies on other teams. And actually, when you're doing DevOps and you're shifting left all the things that your developers should do, the cognitive load is getting increased. And platforms or internal developer platforms aim to reduce that cognitive load by actually abstracting complex processes and infrastructure details to allow them to focus on their core tasks. And your IDP should be actually offering optional and composable services, so every user can like choose which module he wants to use. And one last important thing that's pointed out in the white paper, and that's actually the focus of this talk today, is IDP is actually secured or secure by default. And the white paper is saying a platform should be secure by default and offer capabilities to ensure compliance and validation based on rules and standards defined by the organization. So how can we do that? Actually, this is how an internal developer platform can look like. And in circles, I have actually put in the Datadog platform where it actually appears. And when we go into the details, we start with the developer control plane. This is actually the plane that is being used by the developers all day. So we are actually right now using the service catalog. It's being renamed to internal developer portal right now to offer our customers, our internal customers and developers a good view of which services are actually there, and also which the developers are also taking care of all the application source code in the version control all day long. And on the right side, you have like platform source code that are actually Terraform modules from that are developed by the platform team. And when you go one deeper, that's actually under the hood, the strengths of platform engineering. All those details that are coming from the control plane, the developer control plane, is actually merged by a platform orchestrator, which is making sure that all the automation in the background and the abstraction that you are offering your users is deployed automatically, right? And there are also other planes like the monitoring and logging plane we are using for observability, Datadog in that case. And something that really surprised me when we started with Datadog 2 years ago, I never would have thought that we actually do also security with Datadog. But right now, in that case, we are doing this. So when we look at the software development lifecycle, how can we actually make sure that our applications that we are deploying and in production are secure all the way? What you see here is there are two aspects that you have to take care of, or that you can take care of. Actually, there is some shift left. That's actually you securing your application at build time, or maybe also before build time. Some famous application security testing methods is the static application security testing, which actually analyzes the source code without running the app. So you know that like Sonar Cloud, even Datadog offers a solution for that. So you scan your code for vulnerabilities or known patterns that are actually bad, and you get insights into that. Another one, and this is one that we are gonna dive a little bit deeper next, is software composition analyzing. This actually scans your application for vulnerabilities in the used open source libraries, and it identifies outdated or risky dependencies, and is actually critical for managing your supply chain. And there are also some shift right aspects, and this is actually when you are making sure that your running applications are still secure. So you could like deploy your app today, and there is just no vulnerability found. And like in the afternoon, somebody is like publishing a new CVE, a new vulnerability that is also in your application. And you want to make sure that you find out post-production in your runtime that this vulnerability is there so you can fix it. Okay, like I said, I want to deep dive a little bit deeper into software composition analyzing. So first of all, we're going to look at the shift left in practice. And like I said, I'm a product owner. I care about my customers, and I talk to them every time. So in that case, I'm asking Maria, hey, how do you actually make sure that your application that you are developing is secure? And she's answering me, while developing, I need fast and clear feedback on any security risk of my application. And now the important part, if the platform lets me deploy, I trust it's safe. So what she is going to tell me is like, she's not a security expert and she needs help and she trusts, or she wants to trust the platform that she's using, right? And she also adds like, if not, help me understand what's wrong and how to fix it. This is also an important part, and I will show you how we can do that. So going a step back, once again, how can we actually make Maria happy and offer her the thing she needs and she requires? So there's when you look at internal developer platforms or platforms in general, there's a concept around that's called golden path. So a golden path is something like a template that everyone can use. So the developers are actually consuming them. And one example is like an offering for a Spring Boot Java application, right? And within that golden path that is actually developed by the platform team, and maybe if you also have a dedicated security team, they're gonna also contribute to that. What's containing within the golden path is stuff like a code skeleton, the CI/CD pipeline, deployment manifest, security aspects, like I said. So we are actually making sure that, for example, in the CI pipeline, there is a step that is proactively scanning for vulnerabilities, and so on. So this is actually something that we have to develop in the platform team. So how does that look like in practice? So let's assume Maria has used the golden path for a Spring Boot application. And she's going to begin developing the business logic, pushing the code into, for example, we are using GitHub, and creates a pull request. Because she's using the golden path, there is an automatically integrated step in the CI pipeline that's been triggered, besides the build steps, that are actually is creating a software bill of materials. That's just a list of all the dependencies your application has. And this file is going to be uploaded to the software composition analyzing in Datadog. And after it's going to be processed, there's a quality gate that you can configure with rules where you can say, okay, if there are critical and high vulnerability found, please block that merge so that the developer is not able to merge that new introduced code, that vulnerable code, into your trunk. And the developer, so in that case Maria, has to make sure to fix that before she can merge it. The purple circle in that case is everything that's happening within Datadog. And like I said, it's a part of the CI workflow in the pipeline. So when there is a block, or when the merge is being blocked by the pipeline, Maria can actually look into some logs in the GitHub action, and this one is running a Datadog CLI tool, which is evaluating if there are any vulnerabilities. She's gonna see here, okay, it's failed, and she has a link down there to dive deeper into details, what vulnerabilities are actually, or what vulnerabilities she actually has to take care about. So when she clicks on that link, she's going to go to Code Security in Datadog, and she's going to be presented with this list here. So right now, did find 2 vulnerabilities that are high, that have the severity high. And she can also go into details. So like she already mentioned, help me if there is anything I have to fix to understand. Well, help me to understand to fix anything that's been found, right? So she gets all the details laid out, provided by Datadog, what is actually happening and how she can fix it. So here in that case, she just has to upgrade the package version. So Maria is happy. We, as a platform team, we actually work also in sprints. So we use Scrum. We do a review. Everybody is happy. Developers are like happy. And then Alex, my head of IT, is reaching out to me and saying, okay, securing code before deployment is essential, definitely. So I'm happy with that. But it's only a part of the whole software development cycle. So we also need continuous visibility into what's running in production. So we can catch newly disclosed vulnerabilities and act on them immediately. So this is actually the shift right part that I already laid out before. So we want to know what's going on in production right now. Is there anything vulnerable that we have to fix? Is there something new? So what we can do here is Datadog is offering also a separate product for that. And what you can do here is you have the ability to create new alerts in Datadog where you actually can define which vulnerabilities are of interest for you. So you can also include this alert by using infrastructure as code within your golden path. So when a developer is, like I said, creating a new Spring Boot application, for example, we will automatically create an alert for that team, for that specific new app in Datadog. So every developer within that team is going to be alerted when there are, in that case, medium, high, or critical vulnerabilities are found. And when there is an alert, the developers are getting also, once again, a link. They can click on that. They can actually go into Datadog and see much more details, once again, about the vulnerability that Datadog is complaining about. And going a little bit more into details, you actually see, once again, all the information that you need. So it's going to be explained what's happening. You're going to get the next steps, how to remediate it. You're going to see when it was first detected, which services are vulnerable, and so on. So that's really great. But the next one is much greater, I think. So when you use open source tools to scan for vulnerabilities, you're not getting such a feature like in Datadog. So I really like that. So what's happening here? The severity breakdown in that case, what's happening in Datadog is taking the base score out of any database it's consuming to know which vulnerabilities are out there, and it takes a lot of other filters into account. Like, is it running on the production environment? Is it a real-time threat activity that's right now going on? And is there also an exploit available? And if that's actually not the case, it's lowering down the severity score down to, in that case, from 8.7 to 2.3, and it's helping the developers and anybody in the company actually to filter out not relevant vulnerabilities, because you can expect that you're gonna get false alerts, false positives, and that lowers down a little bit the alert fatigue. When there are actually false positives, we are an insurance company, and we need to make sure that we obey the regulations, and we want to make sure that nobody is like muting any findings if that's not the case, right? So what we want to implement in the future right now is we want to have an app in Datadog. So we're going to use the app builder for that, where the developer can put in the CVE ID, the application name, the reason why do you want to mute that. So is it a false positive? Is it a risk that we accept actually? And the expiration date. And when the developer is submitting that, a workflow is going to run in the background and create that mute rule. Because we are required to have an expiration date, we're going to check regularly. So this is going to be done by Datadog if that expiration has been, gone through. And we're going to actually deactivate the mute rule so that we that we constantly check if that vulnerability is still not relevant, right? This is actually a work in progress because right now we cannot utilize APIs in Datadog. They are actually missing in that case right now, so it's not possible to create APIs, to create mute rules using APIs. But I'm in talk with the product managers, and we're going to get this fixed. All right, so I don't know how many developers are here or operations guys. I think we all have been there. So alert fatigue is a real pain in the actually, what I want to do is right now is showing you two things, how you can improve your user experience and avoid alert fatigue. First of all, there is a nice muting rule that you can utilize in Datadog. So when Datadog knows there is no exploit available or even no fix for the vulnerability, you can actually use that filter to filter out anything that's not relevant yet. So if we cannot fix it and there is no exploit known, I don't really care, to be honest. If that changes any time in the future, Datadog is detecting this and the mute rule will not apply anymore. So you are sure as soon as there is a fix available or something like that, that you're gonna get alerted. And something else that we also using at andsafe quite heavily, to be honest, we are patching our library dependencies automatically. We are using Renovate for that. And what we are doing is, or what the Renovate bot is doing, it's scanning all the dependencies every day on a regular basis. And it's going to automatically merge patch and minor versions into your code base. We do explicitly only automatically merge patch and minor versions because when you do it for major versions, you might get conflicts because there are changes in APIs, whatever. So that's one that you should avoid. And this is helping you to avoid the alert fatigue because you are already up to date all day long, right? Every day, if there's a new patch version out there, you're gonna get updates on that automatically. And another quick win is you don't have to worry about any unsupported libraries. So right now I only talked about developers, but my team, we as a platform engineering team, we also need help, actually. So right now we are using the Shift-Right product of Cloud Security Management to detect any open vulnerabilities in our infrastructure. And what we want to do is, in the future, to also shift left. So right now there is a beta version out, a beta product in Datadog called IAC scanning, so infrastructure as code scanning. And we are highly interested to get this working, because when we use this, we can actually also scan our infrastructure code for vulnerabilities right before it gets deployed. Okay, so to wrap this up, I have 3 key takeaways. First of all, internal developer platforms reduce the cognitive load of your developers. So when you abstract away complexity from the developers, they can actually focus on building features and not wrangling with security findings. Golden paths, if you do it well, they're gonna be chosen and not be enforced. So this actually allows you to scale compliance and make your visibility and improve your visibility and your security posture. And by combining a Datadog code security with an internal developer platform, you're going to be secure by default. That's it. Thank you very much.